Hello, this is Mr. Stansbury. I'm going to show you how to do power regressions on Desmos. Okay, so this is for those of you that don't have a TI-84. This is what you're going to have to do. Okay, so let's say if we've got some data here. We want to enter this data here into a table. So what we're going to want to do is go over here to the add item, add a table. And then what we're going to want to do is we're going to want to enter each one of these. These are all of our X's, and these are all our Y's. The way Desmos does this is you have to enter 3 and then 50, 5 and then 18, 9, 7 and 9.2, so forth and so on. Okay, so when you do that, you will do 3 tab 50 and then you tab and it'll go down to the next piece and you just enter in all your data. Okay, so I've got all my data in here. I can zoom in or out to get it so that it all fits on there. So I already did that. You can like scroll up, click on it first, scroll up or down to zoom in and out. So I wanted to see all my points there. That looks pretty good. So now what we want to do to perform a regression on this is we are going to, I'm going to just do that up here, add an expression. Okay, so now here's what we're doing. Here's our Y and here's our X, but it's Y1 and X1. So what I'm going to want to do is put, instead of Y, I want to do Y1. So I'm going to simply type Y and then 1. It knows that, Desmos knows that if you type a 1 after these variables here, it's just going to give you the subscript. Okay, so Y1. Now, here's the weird part. You got to click the tilde, which is shift and then to the left of the 1, and it's also called the twiddle is what it's also called. So shift, the key that's to the left of the 1, there we go, and that says Y1 is regressed against, and then whatever we want in here. So let's say if we want to do a linear regression. This doesn't look linear, but just so we kind of start with the basics here. So we want to do, basically it's Y equals mx plus b, right? So we put m in for our slope, or it can also be our k value for all of our direct and inverse variations. So we put our m in there, and then we're going to want to do x1. So again, you type in x and then 1, and it'll give you your x sub 1. And then normally it's plus b, right? So it goes through and it gives you your regression line right here. Now that doesn't look like it's super close. And then actually there's this cool little thing here, this residuals. You push plot, and then it's going to show you how far away your points are from this line. So like this point right here, if you go down to where it actually hits the line about that far, that's how far up that is right there. And this point is below the lines by from here down to there, so that's why this goes all the way. There's going to be another point. There it is down there. Okay, so those are the residuals. We want these dots to be as close to the x-axis as we possibly can. Okay, so we can tell it's probably not a linear regression. Try to ignore the purple points. We're looking for the red points here. So this definitely looks like it's going to be some kind of inverse variation. So what we want to do is we want to have m over, so we simply put the slash sign, and it's going to give you division over x1. So now we've got inverse variation. So now if we look at that, that's a little closer, right? Look at these purple dots are now getting closer to the line here. It looks like it's still not quite beautiful. So let's try m over x squared, or in our case, k times 1 over x squared, right? So simply just put in parentheses, and you can type those in, just shift 9 and shift 0, right? And then now to do the power, you want to do shift 6, which is the caret, the up arrow, and then we're going to do squared, and then look at that there. All these residual values, all those things are really close to 0. In fact, our r squared value is 1, which means that in theory it fits perfect. You can tell these line dots are a little bit off, so it's like really, really close to perfect. Okay? And if you'll notice, this b value is negative 0.0005. We really don't need this b value on there, so we simply take that off there. And that's going to tell us that our equation is going to be y equals k times k, and our k value is this right here, 449.989. So it's basically 450. So it's going to be y equals 450 times 1 over x squared. That's going to be our regression line. Okay? All right. If you have any further questions on any of this, please feel free to ask. Thanks.